Hello and welcome to my presentation entitled "What's My Future?", where I will try to give a glimpse of how we designed and built a new kind of multisensory and multimodal digital human experience. And we demoed it at Web Summit 2022 in Portugal. So the demo looks like this. There was a screen showing a digital human agent and a podium that housed hand tracking and media haptic technology that a user could walk up and interact with. At the end of a 2-minute experience, a printer would produce a small card that contained a link and a QR code to an NFT and a 3D rendered avatar of the user. The demo was basically a creative take of what you get when you combine public displays and the phygital metaverse. And I will explain more about this in the next few slides. I should say that whilst the paper is a collaboration between Softserve and Ultraleap under the TOUCHLESS AI EU funded project that involves several other academic partners, most of the work that I will be presenting was done by the guys at Softserve in Poland and Ukraine. And so our work has a clear industry focus. So this is basically my excuse for not presenting any user studies in the following slides. So this is a snapshot of my presentation outline, and let's get started with some background. So there's a few examples. These are a few examples of deployed or under development applications of digital human agents. Usually, they'll be used for customer service type of applications in shopping malls, museums, airports, and also increasingly in whatever the metaverse is. And usually, these avatars will live on a screen or on a tablet, on a big wall with a projector, or maybe on an AR or VR headset. Common components of these kind of realizations include a screen, a bunch of sensors, usually a microphone for voice input and interaction, and also a natural language processing model that runs in the background and interprets this voice input. Now, market analysts and various reports are projecting that we're going to be using and seeing these kind of interfaces increasingly proliferate in the next few years. And this is despite some of the known voice input problems, like reliability in a noisy environment, like in a shopping mall, museum, and airport, social acceptability, and also privacy concerns, and the lack of multisensory and multimodal alternatives. So this is the background. This is what got us thinking. And just as a note, when I say multimodal and multisensory, these are large fields of research in themselves. So I'm just going to generalize here and simplify and refer to different types of user inputs for multimodal. So voice, touch screens, facial expressions, hand and body expressions as well. And for multisensory, I mean system feedback. So audio, visual, haptic, and olfactory. Ultimately, the aim of introducing multimodal and multisensory into these experiences is to create a more intuitive and engaged overall interaction. So in our contribution specifically, we will be using the ones that I have just highlighted now here. So facial expression input, hand or body gestures, audio, visual, and haptic feedback. So now, before I show you a short clip of the experience, I just want to give some more background about how the whole kind of journey comes across. So on the left is our setup of what's included, and you will get a good idea about it from the short clip. And on the right is what you'd call a user journey. So it's an interactive experience. So people are attracted to it. They come in. They're attracted to this podium that we have at the center, just in front of the screen. and that's where they receive some instructions from the screen, from the digital human avatar of what to do, and then they interact. There is a narrative. They then move over to the printer and they pick up their NFT card and they leave. So this is how they come in and leave, and this allows for a very fast turnaround of interactions with this interface, with this experience. On the bottom of this slide is the same, but now on a timeline. So we can see that there's an important point here, that there's a pink block, and it's an element of obtaining the user's consent before having the experience, because this experience is a tactile experience, and we're also using facial expressions. So there is a need to obtain that consent. And I'll come to this in a couple of slides about how we obtain that consent. Okay, so on to the short clip.
Digital human agent who is a gender-neutral, multi-ethnic, multiracial, and give them the power to see the future. In the center of composition is a digital signage kiosk, along with a podium that is embedded with mid-air haptic and hand gesture recognition hardware.
I knew you would come.
The kiosk provides a visual component and displays Al-Nair, whilst the haptic device provides a tactile feedback component. On the top of the kiosk, there is a web camera that allows Al-Nair to scan the user's face in order to generate a digital avatar of the user and predict his future. There is also a mini printer that prints the card with a digital ID of the user. In doing so, we want to promote and provoke discussion on topics such as how these novel technologies could be integrated to produce engaging new digital signage experiences, not limited to this specific demo implementation, while also highlighting the increasingly important aspects of privacy, consent, and gender neutrality in the metaverse.
Okay, so this is the system architecture of what you just saw. So I will run through this briefly, and I will explain how everything is kind of glued together. So on the left is our haptic podium, which houses a leap motion camera for hand tracking of the user that comes to interact, and also an ultra haptics device for delivering tactile sensations onto the user's hands in a contactless, touchless way. So we also use footprints and also handprint to help the user position themselves correctly during the interaction. For those not familiar with these two interfaces, so leap motion camera uses optical sensors for and machine vision to accurately track a person's hands and fingers, whilst the ultra haptics device uses an array of ultrasound speakers to send a tactile vibrations onto your palms that is you can feel and sense. So returning back to this slide of the system architecture, we also have a screen that displays the human avatar that we developed and named Al-Nair. We have a webcam for capturing the user's face, who is standing right in front of this podium, in front of the screen. And we take that image that is captured by the webcam, and we apply a deepfake face swap algorithm that runs locally on a local machine through a Python server that maps onto an avatar template that we have built with also a random fortune, because it's an Oracle application, a fortune telling application. So we have a list of possible fortunes that we just pick at random and assign to this new avatar that we have created. The server also mints a fortune website, just a landing page, and it mints it on an NFT, and then creates a QR code to that website and to the NFT, which are then also printed by this mini printer on the side of the podium, so that the user can take this printed card, a physical, takeaway that they can then scan using their phone and obtain the rights to their NFT and put it in their wallet. So for this fortune-telling interactive experience, we had a lot of different conceptual analogies during the design process, and we tried to embed them in what we wanted to build and why we wanted to explore all of these things. So first, there's on the left, there's the tactile element of a fortune-telling experience, which is palm reading. And this is where we used the media haptics technology to come in. And we also wanted to design, we also had to design a variety of different tactile sensations and couple these to the narrative during this palm reading. So, for example, there's a point in the narrative where the digital avatar releases some magical sand dust. You could feel this sand dust on your hands, and that's where we used one of these sensations to feel that. Secondly, so this bottom picture here is showing part of the prototype. So we didn't reach the final polished version that you saw in the little clip directly. We prototyped and iterated using just some cardboard boxes to get everything right and aligned in terms of ergonomics. So the second analogy that we wanted to make is a tarot fortune card experience where, and these were realized through the NFT printout. So, for example, here's what Pavo's metaverse fortune looks like. So apparently he is a meta weather designer in this alternate universe. It doesn't really mean something. It's just a fun part of the experience. So then we, at center stage, we have the Oracle, who is something we spent a lot of time working on. They were the main agents, which we realized through this character called Alnair. So Alnair was computer generated by mixing several characters of different genders and different ethnicities. And we also used a motion capture to lip sync and also animate Alnair. So finally, we wanted to augment the typical checkbox to accept terms and conditions that nobody really reads. And for that, we used different gestures that would also provide the user with a heightened sense of agency when agreeing to have their face recorded, for example. So this brings me to my final slide, some guidelines and key takeaways. So the interaction podium hand and footprints communicated interactivity and enabled a walk-up and easy-to-use experience. These phygital interactions, which is where the physical meets the digital, they do not need to be constrained on a head-mounted display. Digital human agents can be designed to be more inclusive, and human to digital human agent interaction can be multimodal and multisensory. User consent should be obtained, and if possible, it should be obtained using agency and efficiency without breaking the interaction flow of that experience. And finally, the ergonomics and UX design factors can be tried, tested, iterated using mock-up prototypes, Wizard of Oz, and body storming sessions. So thanks for your attention.